Hello friends, welcome to my YouTube channel Easy Aviation. Here we discuss about the short simple topic about the aviation fields. Today's topic of discussion is barometric altimeter. It is made up of two words, barometric and altimeter. Barometric is the study of the air pressure and altimeter is any device which calculates the height. So I'll cover the definition. Definition is barometric altimeter is any device which let us measure the height utilizing the air pressure of the surrounding. Since I have already discussed about the atmosphere in one of my video, I'll share the link. So how the parameters, not only the pressure, temperature, humidity and other many important parameters, how they are changing as we are going up in the atmosphere, I've already discussed in one of my video. So from that also, and it's an idea that as we go up in the atmosphere, the pressure reduces at a rate. So using that change in pressure, we can actually calculate the height or the altitude at which any object or the aircraft is. So this is the definition, and this is one of the key device in any aircraft. There are other method also, like altitude can be calculated using a radar, that is known as radar or radio altimeter. From the GPS also we can calculate the height, but during the complete electrical failure or any issues with the devices, with the power supply, this Baralt comes handy, since it is not utilizing any power source or anything, since it's a digital, it's a mechanical gauge, and which is only utilizing the pressure which is there outside. How the baro altimeter works, I'll discuss in the principle of working. Okay, so second topic will be QNH, QNE, QFE. What are these pressures? How the height is calculated using these pressures, that I'll be discussing. And these two I'll be combining, pitot static tube and principle of working of the barometric altimeter. So that will be coming ahead. So second we'll go to the QNH, QNE, QFE and QFF. What are these terminologies? So let's say the tower or the airfield is at 1000 feet above the mean sea level. Let's say this is the sea and this is mean sea level, this is 1000 feet, and one aircraft is there at 2000 feet from mean sea level. Okay, so if aircraft is calculating, okay, since this 2000 feet, 1000 feet, he is checking it in his Barolt. So the Barolt should be aware about the reference, which reference it should take. So if we set, okay, how to set, what is this setting, I'll be covering in the next slide. So for now, just understand there is a digital analog meter, and there is a knob through which you can set the pressure. You set the datum pressure, and the present height is being depicted or being shown in this gauge using that base pressure. So let's say if the pilot wants to know the height from the mean sea level, so he can use as per the ISA condition, the mean sea level pressure is 1013.25, which is standard, and which is standard all over the world. So if he is flying very high and there is a air traffic at that height, I'll just draw it here. This is mean sea level and there is an aircraft flying and there are other aircrafts flying. He wants to know his height comparative to the other aircraft. Since they are all are flying at a very high height, and they are not approaching downwards, and they are flying in the environment, in the atmosphere, so they all can communicate and set their datum pressure, which I was discussing here. They can set their datum pressure to 1013.25, and their actual height from the ground, since they are in that pressure area, they will communicate to each other at which height they are. So when they set the pressure of mean sea level as per the ISA condition, that is 1013.25, this is known as QNE pressure. This pressure is known as QNE. Okay, 1013.25 is the pressure as per ISA condition, but there is a possibility that on that day at a particular region there is a different pressure. It could be 1012, that is, well, okay, I'll just write 1013.25 is the standard. It could be less than 1013.25 or could be 1014.5.6. so there could be any value. So these values are calculated for the particular day using mathematical formulas, and that value, if the height is calculated using this value, that is the mean sea level, the actual pressure of that day, that is known as QNH. So generally the flight which are flying near the shore, and if they are approaching towards the ground, during the approach they use QNH so as to reduce the error. Since QNH is the most accurate value, like if the pressure is very less, 1005.6, let's say this is the pressure of the pressure at the on that day of the mean sea level, and if we are taking 1013.25, during the landing there will be a huge error of the height, like the aircraft will land at 1005.6 pressure, but if he set the 1013.25, the error in the height, well, the gauge will not show 00, because he has set the 1013.25 as per the QNE. So if they are approaching, they have to set it to the QNH value so as to get the most accurate value while landing. Coming to QFE, QFE is something is the pressure. QFE is the pressure of the ATC of the place which is at some particular height. Basically it's not about the mean sea level, it's about the AGL. So I'll write it here. QFE tells the pressure of the area, and the height which tells about the height above AGL. I write above ground level. So if we put the pressure of QFE in this datum, the height which they'll show will be the height from the ground. So the ATC will not tell the pressure of the mean sea level, which I have told 1005.2 or rather 10 any pressure. It will not tell the 1013 which is the standard. It will tell the pressure which is there at the at this level. Let's say if it is the 2000 feet, 3000 feet, there could be the pressure. I'll just write QFE for more understanding. If it is a QFE and the altitude, like let's say altitude is 1000 feet, the pressure there might be 983.6 millibar. So if the ATC is telling this pressure, that means the height which will be calculated in the gauge will be from the AGL and not the sea level. Okay. QFF is the most accurate reading used for chart plotting. It is generally not used for the height measurement, but during the chart plotting it consider other atmospheric parameters like humidity, temperature, and while plotting the chart it is used. So QFE is not during the communication calculating the height, however it is used for the chart plotting. QNH important when the aircraft is approaching and taking off. QNE is the standard. So if the aircraft is flying very high, commercial airlines like, so they fly in on QNE on a straight and level flight when they're flying at very high height. During approach and takeoff they use QNH for the most accurate reading. QFA is above the ground level, so that is another reference that pilot can take. This is very important aspects. I request you all to please make a note of these points. They are very important while calculating the height. Okay, coming to the next slide, coming to the Baro altimeter. So Baro altimeter, how does it work? So as we go up in the height, the pressure reduces, and there is a static port which actually takes the static ports. Okay, I'll just go to the next slide. Okay, I'll just give you the examples of pitot and static. What does pitot static tube means? So as you can see in the pictures, this is a commercial airline, and as you can see here, they are the pitot tubes, and the small this area, if you see, there is a static tube which is just a box and a hole in it. And pitot tube is this, as you can see, this is a pitot tube of a small Cessna training fixed wing pilot, fixed wing aircraft. So this is under the wing. This is another example of pitot static tube. In the fighters, mostly it is in the nose area, and the aircraft, helicopters, you can see this is the way the pitot static tubes are fitted. If we go the schematic diagram, this is how the pitot static tube looks inside. So there is a concentric hole. Basically there is a inner area in which the dynamic pressure, or since the aircraft is moving ahead, the pressure which is going is a dynamic and static pressure which is going inside. And this is how the total pressure is calculated, which is the summation of dynamic and the static pressure, and the pressure of the atmosphere at a particular height. Let's say this is an aircraft flying, and it is flying at some velocity. So the pitot static tube, the pitot tube, okay, so this the tube which is, there is a, okay, so this is a pitot tube, there is a hole, I'll just draw, there is a hole ahead and there is a hole on the top. So since this hole will counter the pressure of the air which is coming ahead, plus since this aircraft is at some height, so this hole which is there in the front will counter both dynamic pressure and the pressure of the atmosphere. However, the hole which is there at the top, or like in commercial there is a separate port which is given, this is only encounter the static pressure, like which is the pressure at the particular height, 1000 feet, 2000 feet, 3000 feet. So this is the static pressure, and this pitot tube, this tube is handling both. So that's why the total pressure is coming pitot plus static, and these holes which is there at the top only taking the static pressure. I hope this part is clear. I have already discussed this part in one of my videos, so I'll again put the link on it. So coming to the baro altimeter, how it is working. So as I've told, this is the gauge. This is the part which I was telling you to set, like this is where you put the QNH pressure, that is the mean sea level actual pressure, QNE pressure which is a datum 1013.25 millibar or hectopascal, or QFE, the pressure of above ground level. So this is the pressure, you take it from the ATC, from the tower, and you feed it into that, and that will become the datum. This is the knob which is written adjustment, which is required to adjust the pressure. So once the datum is adjusted, the same correction is provided here on the bellow. Okay, this is a empty tube. So as we go up in the air, like at the ground level is 1013.25 as per the ISA conditions. Since we are going up, the pressure reduces. Generally for easier correction it is taken as 30 feet is approximately equal to 1 millibar. So as we go up in the height, this minus 1 millibar, so that means every 30 feet up leads to results in the reduction of 1 millibar pressure. So as we are going up, reduction in the pressure, so this reduction in pressure is sensed by the static tube, and that is goes inside the chamber. So when it is at the mean sea level, outside pressure is equal to the inside pressure, which is 1013.25. I'll just change the color. So here the pressure is 1013.25. So altitude is showing 0. If we set, okay, a very important catch, if we set QFE pressure inside this, the height, the altitude which is shown in the gauge will be equal to the elevation or the altitude of the field, airfield. So let's say the airfield is at the 1000 feet, and here's a mean sea level. So if mean sea level pressure is 1015, let's say, and the pressure here is 985, so if this is a QFE pressure, so and this is the QNH pressure, so if pilot is feeding 985 millibar, so it should show 1000 feet into this. I hope you understood the relation between the QFE and QNH. And if it is showing the QNH value into this, the altitude, it will show the same which is there at the height. Okay, like 985 it is feeding, it should show 0, and if it is putting QNH, it should show the height of the this airfield. Coming to the height, as the aircraft goes up, the static port is reducing. That will increase the size of the bellow, and as soon as the bellow increases, which is calibrated to the linkages, and accordingly the height in the baro altimeter changes. So important part is to set the datum, which value you want to see. Static port should be clean, and that's it. As you go up, static port will check the change in pressure. The pressure outside the chamber reduces, which leads to the increase in the size of the bellow. Bellow will start inflating, and inflation of the bellow will the movement of the bellow will be passed through these linkages, and that's how the height will be shown in the aircraft. So I hope in this video I have made clear about the definition of the baro altimeter, what are the QNS, QNE, QFE pressure setting, and the pitot static tube, how it looked like, and the principle of working. Here I conclude my video. I hope this is an informative video regarding the basics of baro altimeter. If any particular doubt is there, please leave it in the comment section. I'll try to make another video. I'll try to clear the doubt on the same. So here I sign off. Thank you. Thanks a lot. Bye.